In class today, we're going to be continuing our sort of our high-level review of best practices, or greatest hits best practices, as it were. Normally, a few years back, if you look at me teaching the class, there were topics here took us all the way through most of the class, and what I realized is that students didn't have some of the basics in hand, the key understanding of the motivations for and what's expected for each of these components to get going. So, later in class, it might be talked about defect estimation, it might be talked about peer reviews. And it's only then, halfway through the term, or 3/4 of the way through the term, they understood what an inspection is or something. And that just doesn't cut it. Pedagogically, it's kind of nice and pristine plan, a very nice sequence, but it really didn't help the teams as much as they can. And ladies and gentlemen, I want to communicate to you in the strongest terms I can that I'm discussing these things not because they're intellectually interesting, not because merely they're practices out there in industry that you folks will have to know upon graduation, but because these things will help you succeed in this class. Let me turn that around. These things will help you avoid crashing and burning in this class as a team. And I don't use those terms lightly. It's happened, time after time. Every few years there's a big sort of wipeout, and invariably the team that wipes out has neglected some key processes. Okay? These are best practices for a reason, because they tend to work. They're not perfect, they're not silver bullets, but they help you avoid and dodge a lot of the biggest vulnerabilities when it comes to software projects. Okay? They help you let me put it another way. They help you put your effort, help you pour your inspiration into the areas where it makes a difference, instead of just fighting fires all day, instead of struggling with coordination issues. They help take that limited energy you bring to bear between your other classes and let it take you further in terms of your technical vision. So this ain't a bunch of fluff. These are things that you're going to be putting into practice when you go into industry, company after company and so on. But there'll also be things that are going to be in part of your survival kit in this class. One of the books I recommend for this class is Steve McConnell's Software Project Survival Guide. And that discusses many of these things. And I'd like to suggest that you consider looking at that book and another book, Code Complete, by the same author, which helps orient you to many of the key aspects of these processes and so on. But I'm going to be hitting on a couple of these today, and I'm going to be hitting on several others during our next two sessions, with the proviso that the next session of this class will have an awful lot in the way of project presentation related pitches. Okay? So here are best practices that we're going to be talking about. You recall that last time I talked about accountable positions here, and I'm going to start with discussion of risk scanning and risk management. So the quip is that today's risk is tomorrow's problem. Why do we talk about risk? Why do we talk about uncertainty with consequences, which is really what a risk is? We're uncertain about something, and it matters. It matters in terms of whether we're going to be able to succeed or fail in our project. It matters whether or not the client, the stakeholder, will be happy with our results. And I think it was Weinberg, Steve Weinberg, that said, if you don't aggressively attack project risk, they will aggressively attack you. This is not, again, merely theorizing. I've seen it again and again in this conference. And I mentioned to you some risks last time that materialized. People dropping the class, but also things like break-ins to servers, also things like technologies that didn't work out, also things like code cowboys that didn't allow other people to understand the code or to aggressively move it forward, etc. And I turn these around and saying, fortunately, not only is today's risk tomorrow's problem, but today's problem is tomorrow's risk. Meaning that we can learn from our experiences and do things better. And ladies and gentlemen, if there's one thing that this class should be about for you, the experience of the project should be about for you. It's the experience of learning by doing, learning not only on the technical level, but learning about processes, evolving your skill and how to undertake these key best practices. And risk management is a good example of this. Risk management is an ongoing process that you're going to be practicing through this course. And good risk management is something that allows, it's a differentiator between companies and between projects out there in industry. It's what allows a company to undertake higher yield projects that will be unduly risky. If you go look at the software landscape, if you go look at the commercial software, you'll find that there's certain areas of that space that are very well understood and that everyone and their brother and sister can work on because there were known technologies, known issues, and the barriers to entry are very low in terms of risks, in terms of uncertainties, in terms of technical finesse required. And guess what? The return on those things is pretty low. What do I mean by return? Anyone? Okay, positive results, and I'm particularly talking here about financial returns. In other words, undertaking things, several years back it would have been doing VB programming, Visual Basic Programming, and so on. I mean, this is stuff with very little barriers to entry. Lots and lots of people can do it, and there's lots of competition. So if you're doing contracting in that space, if you're a firm and you do contract work, you build software for people on demand. So you build it for companies in town or for organizations. You'll find that you could earn a decent living on that, but you couldn't get as much per hour nearly as if you were doing cutting edge stuff. You're doing Erlang programming. You're doing stuff which allows multi-user coordination live, real time, sort of like you see in Google Docs. Where multiple people can contribute to the document at the same time. That is non-trivial stuff, and that requires a higher level of technical finesse. And that, ladies and gentlemen, it's at that bleeding edge that often people are willing to pay an arm and a leg to get it. And there's few competition, hence you can charge more. And a lot of the trick for doing that is to manage the risks. A lot of them are technical risks. Some of them are HR risks, human resources risks. You got to attract and keep the best people in those areas. If you lose them, you're not going to be able to pursue this. You're not going to be able to hire, just so-and-so or your cousin to come in and stand in for the work while you search for someone else long term. It ain't going to happen. You need the best people. So good risk management is often what allows a company to undertake projects that offer higher return, that offer bigger financial gain. It's what allows a company to succeed, to grow quickly, is its ability to do good risk management. It may differentiate a company that succeeds and fails. Effective risk management. Why? Because it allows avoiding many problems, and it allows resilience to inevitable problems. Things come up, ladies and gentlemen. Please understand this general point. The risks that materialize, the fire, should not be viewed as exceptions to what this class is about. Oh, Merlin was out sick, and you couldn't get your VM fixed after it was hacked for 6 extra days. I get these sort of requests all the time from students. Oh, thing happened, and the tech staff was out, or we had that big snowstorm, and we weren't able to get together as a group, and because of that, we couldn't finish things for the client in time. And the litany can go on and on. Our best person was out sick. Our best person dropped the class. It's easy to look at those things as like lightning striking. It's just a chance thing, and now we're in trouble. No way we could have predicted it. Bullcrap. You might not have been able to predict it, but you could have made yourself less vulnerable to it. You could have anticipated there's a risk of this sort. We don't know who it is that might drop the class. But we're going to train people on our team to have overlapping knowledge and responsibility. So no one person, it lowers our bus number. How many people have heard of a bus number for project? you want to mention what it is?
But I've heard of
Okay. So the idea here is, folks, you want to reduce the number of people that on your team, so that if they were to get hit by a bus and end up in the hospital or worse, you wouldn't be out of business. You want to reduce the vulnerability to someone walking out the door or losing someone. You want to have a team that's resilient, where people have overlapping skill sets. So if one person's sick, or one person gets hired away, or one person takes a long vacation, someone else can stand in for them. You want to increase resilience. You want to have a structure that anticipates possible risks and put into place mechanisms for dealing with them. And we'll talk about what some of those mechanisms are. Mitigation and contingency planning. Its ability to have resilience to these problems allows greater lead time for dealing with them. You see them sooner. It smells like this thing may be coming up, so I'll start working on it sooner. Or you have a known strategy you just fall back to. Okay, if the project manager is not available because his class load is pretty high this term, well, if this other person being shadowing him so they can step in if he's not available. If this other person stops responding to emails like this happened before, then we'll make sure that there's another build master, someone who knows the build master's jobs. Okay, and this helps bound uncertainties. And it helps you from just sort of inadvertently transferring risk to something else, transferring it to the area of human resources from the area of money or what have you. So let's talk about what risks are involved. I should note that all of these things, ladies and gentlemen, these best practices, for most of them, I'm going to be going back and cover these in more depth. So I want to just do the greatest hits here, okay? I'm just trying to get you the basics. And forgive me if I just rush through some things and go through some slides, because we'll be coming back to this, okay? So what are the key components? Risk identification. I want you to be asking, what risks are there out there? This is not a pie-in-the-sky exercise, an asteroid could hit next week, or, it could be an earthquake, the building could fall, and so on. You're going to be wanting to focus on things that are either that have high exposure. By risk exposure, I mean basically, we often quantify it as the product of probability and damage if it occurs, the expected value of damage from it. You've seen expected value in statistics, I think? Expected value of a random variable? It's the sum up over all probabilities of the value of the random variable. So all possible values of the random variable times the probability of that actually occurring. So risk exposure. You want to minimize your risk exposure. You want to identify risks that are either more probable or more damaging if they occur. And then you want to think about how we're going to handle them. You want to be conscious about this. This isn't going to be perfect. You're not going to be able to do it for every risk. And that, ladies and gentlemen, is a lot of the underlying truth about project management. We're never going to be able to be perfect in our testing. We're never going to be able to be perfect in our reviews. We're never going to be able to be perfect in our risks. But at least we can avoid being bad in these things. At least we can avoid being bad, leaving wide open holes in our risk management. So you try to figure out, okay, what risks are out there, and then which of these really matter in terms of, they're more probable, or they're more consequential if they happen, they're worse if they happen, and take that into account. And then how are we going to handle those ones that are pretty bad? You create, say, a top 10 list of risks, and that's one of the things I'll be asking you to do. I want to see a top 10 list of risks over time for every milestone. So let me see your top 10 list of risks. Be conscious of it. What are you going to do about it? Are you going to try to avoid them, totally eliminate the risk by using maybe it's a risk about a certain technology, D3, you want to put D3 into place, but you're not sure if it's going to be able to work well with Java, so we'll use Prefuse instead for visualization. We use a different technology. Simply, it's too big a risk, we'll eliminate that risk. In others, we'll just accept it. Why am I talking about accepting a risk if I'm talking about mitigating one? Well, look, you want to be conscious about this. You just don't want to brush this under the rug. You want to know, okay, this is a risk, it's possible, and we've decided as a group that we're willing to deal with that. Great, I respect that, okay? I respect that because it's been a conscious decision, not the result of just laziness or failure to pay attention. Or you can try to control it, and this is what I want to talk most about, because most fall into this category, ladies and gentlemen. You either mitigate the risk, you do something up front. This is the key differentiator. This is highly pop quizzable. It's also highly examinable. You mitigate the risk means you do something up front, which either, let me emphasize, it either, students get this off on the final exam, I don't know how many final exams they grade, oh man, I forgot one of these. With mitigation, you either work to lower the probability of the risk occurring, risk materializing, the fancy term for it. The risk, you lower the chance the risk will be realized. Or you work to lower its impact if it happens. So, for example, if we're talking about somebody in the team you're worried about dropping the course, one thing you could do is work to lower the chance that that will happen, but maybe that's taking some load off of them so they don't feel so overwhelmed by this course, okay? That would be one possibility. Another thing you might do is you might work to lessen the impact if it happens. So if they were dropped the course, and how you might do that is have someone shadow them, have someone follow them around, maybe do pair programming with them, right? So that someone else is really familiar with everything they do. So if they drop the course, in that unfortunate case, there's someone else who's just ready to go, seamlessly can go start to do their tasks. If they've been following them around, they've been working in conjunction with them, they know everything they need to do. So that's one strategy, ladies and gentlemen. You mitigate this risk. Another strategy is you do contingency planning. You don't do something too big up front. Instead, you put into place a plan. So if this happens, we will do so. Why would you do that? Why put that plan in place? Because the point is you have a known plan then. So if it happens, you know what you're going to do, and you can quickly act on it. If this happens, we'll do such and such. There's no time to sort of go and have to wait for the next project meeting to talk about it, and confusion because we're away on vacation right now and I can't get in touch with the project manager, and so there's confusion about what's going on and people don't know, so they can't do their work. No, instead you have a clear plan and people can count on it, okay? And there's another one, transferring the risk to something else, just, you know, transferring it to another party, and I won't go into that. Okay, so that's a lot of what I'm asking you to do right there. But there's one final component, and this is key. I want you to do this on an ongoing basis. This is not an exercise merely for next week, or indeed later this week. You could start doing this immediately, sort of risk management. Have your risk officer and your team discuss some of these things. The risk officer will be responsible for maintaining that top 10 list of risks all through the team. But you're going to be wanting to do monitoring, what's called risk scanning. Scanning for new risks or risks that are in the danger of materializing, coming about, that you had identified earlier, okay? And I have some components for this on slides that I'm going to post to the site, but that are on, you know, you can see here on YouTube if you want to, but I'm not going to be talking about them right now. We may be talking about these in more detail later in the term, but you can have sort of a catastrophe brainstorm. You could ask your team, what's your worst fear about what could happen, you know, this term? What are you afraid about? That's one way of sort of eliciting risks, is to sort of ask people, you know, what could go wrong here? How could it fail without being the fault of any one person, for example? You know, how could it fail with being each person's failure, etc. So you go do scenario identification sometimes. Okay, these are, you know, we could have a poor quality demo, or we could have inadequate documentation, what have you. Do a risk prioritization. I mentioned this probability times loss as the risk exposure. And then you have a top 10 risks software. Let me just give you, stuff is amazingly robust year after year. Top 10 risk in software. Well, let me ask this. Those of you who are more acute will have seen it already. Cat may be out of the bag, but what do you think some of the top 10 risks are in software? Tell me. Okay, so there's a possibility of going over budget. What would contribute to going over budget?
Mismanaging time.
Okay.
Or underestimating the time necessary to.
Okay, underestimation. Yeah. So that's good. How about some others? So both those are risks. Yeah.
Data loss due to like power outages or.
In some cases. Yeah, that can be a serious thing. Security, no question, in certain IT spots, that can be a very serious risk. Others?
Losing people.
Okay, losing people. People walk out the door, their precious commodities and so on. These are good. Anyone else? So I like these. These happen to be the top 10. Personnel shortfall. So you don't have to help people, you can't attract them or you're losing them. Again, quality. We're going to come back to this in a big way at the end of the term with a systems view of what's going on in these teams. Remember how important quality is for attracting people. Quality is for retaining people. People don't want to come get hired to work on a piece of crap, and they don't want to stay to work on a piece of crap. They stay because they work on something they believe in, that's interesting, it's challenging, but they get to see it work in a quality way. They like to feel good about what they're doing. Software people are often craftspeople. They like to build something that's quality. And if it's just clunky, big hairball, they're going to walk. So personnel shortfalls are tied up with issues of quality. Unrealistic schedules and budgets. We heard that earlier, and absolutely right. We're terrible at estimation. We tend to underestimate, and we tend to do what? Don't be left. Tend to underestimate how long things will take, and if asked about the best and worst case, we tend to, we underestimate our uncertainty. So if we're forced to give best and worst cases, which is a great practice, we still tend to have way too narrow about. And so we not only are more optimistic, we think we're more sure than we think we should be, or than we should in fact be. We developed the wrong software functions. We didn't pay enough attention to the requirement. We didn't really work with the client enough to really understand what's needed. We developed the wrong user interface. That's kind of related to that, but a particularly in the face version of it, something that they're directly interacting with day to day. Gold plating. You're putting in too much. You're putting in features which aren't really needed. You're spending your time in ways that don't really deliver value in other ways. Continuing thing of requirements changes. The stakeholders involved say, I know I said that originally, but I actually want this other thing instead. And you're buffeted by that. I've done consulting in firms that have failed because of this issue. You have shortfalls in things that you're getting from outside. You're depending on some other company. I've seen big problems here too in consulting. You're depending on another firm and they don't deliver. And the same thing with externally performed tasks. And performance problems. And straining computer science capabilities, straining the abilities of the team. So, what are some best practices here? I want a risk officer, that's for sure. I want planning for risk management. Periodically, I want you to update your top 10 risks. Creation of some plan for each of those risks. Do postmortems. What's a postmortem? Yeah.
Once you completed the task, look back and what succeeded and failed and why.
Good. You try to learn from it. You try to learn from it. Again, if there's one thing I hope you'll walk away from this class with, one thing, it would be the importance of learning from your experiences and observations, successes and failures. Mistakes, failures can turn into successes if you know how to learn from them effectively. If you take the lessons that you can learn from and you apply those going forward, they can be a net gain If you try to cover them up, if you try to ignore them, to not want to think about them, they stay as failures, and they're even worse. They become big things you don't want to deal with, and rule out whole possibilities for your life. So learning from mistakes here, and postmortems are a big part of this. Consciously reflecting, okay, what happened? How can we do it better next time? Not getting into a blame game, but how can we improve the processes? How can we improve our sharing our knowledge? Not focusing on particular individuals and whose fault is it, but what can we do about the process that would make us less vulnerable to this in the future? Let me give you something as prosaic as you find a bug in your system. So one thing you want to do, generally, not always, but generally with a bug is you want to fix it, right? Fix that bug, fix that defect. But a much deeper, more important thing is to ask yourself, why was this defect here, and why did it take us this long to find it in the first place? That will tell you something about your testing process, about your review process. Like, why didn't that review we did of this code catch this? What sort of things were we not learning for? That could help us for future reviews do a better job. It can improve our testing. Oh yeah, this whole series of issues I realized we aren't testing for. That's how this bug went undiscovered until the client, we were demoing it to the client and they crashed it. We never thought to do X. Okay, well, let's figure out if in our testing we can change that to do X. That bug, where did it come from? Was it based on a misunderstanding of one person in the team? Maybe some outdated understanding of what the requirement was? Well, maybe we can share those requirements better. Learning from mistakes, folks. That's what I asked you to come out of this class. Learn from mistakes. One thing. And it's a principle in life. It transcends software, transcends project management. Learn from mistakes. Make assiduous effort to learn from mistakes. Okay? Mistakes, again, can be successes. Failures can be successes if you learn from them. And you may want to have an anonymous risk reporting mechanism for cases where it's sensitive. So I talked about contingency planning and mitigation. I'll put up the slides, but I've talked about what they are. Okay, so these are the components that I expect in place. Okay, so I just talked about risk management, and ladies and gentlemen, I am going